Hello and good morning. This is Mehak Rohra and welcome to the session of the chapter Matter Around Us. In this session, we would be studying about what matter is exactly, different states of matter. We would be discussing a bit about the physical nature of matter. In detail, we will discuss about all the kinds of properties of solids, liquids and gases. We will talk a bit about compressibility in matter, we will talk a bit about diffusion in matter, and then we will make a summary of whatever we learned in this session. So without any further ado, let us begin. What is matter? Well, to explain it in very simple terms, matter is everything that is around you. Everything observable, unobservable is made up of something, and to coin this term, we use the term matter. Everything that you see around you, a glass, a device, a pencil box, a paper plane, a fan, a door, the air you breathe in, everything is described as being made up of something that acquires some space. It has some kind of mass. That is matter. So everything in this universe is made up of material which scientists have named matter. The air we breathe, the food we eat, the stones, clouds, stars, planets, animals, everything, even a small drop of water or a particle of sand, everything is matter. To put it in a technical definition, we would say matter is anything that occupies space and has some mass. Air and water, sugar and sand, hydrogen and oxygen, etc. Matter is made up of tiny particles. Particles of matter have spaces between them. This is the accurate definition of matter. Let us now discuss the physical nature of matter. Well, as I first told you, matter is made up of particles. Any matter, be it the air, be it liquids, be it solids, even be it us, we are made up of small particles, and these particles are bound to each other by internal forces of attraction. If I were to demonstrate how actually this works is if you take any beaker or a small bottle or a cup, and then if you fill half the beaker with water, and then if you dissolve some salt with the help of a glass rod, you have to observe some kind of change that will happen in the water level, right? So what do you think happens to the salt that you dissolve inside the beaker with water? We observe, one, that the level of water does not rise. So we say that the salt dissolves in water. But actually what happens is the inside event that takes place is when we dissolve that salt in water, the particles of salt, they get into the spaces between the particles of water as you see in the diagram that has been presented to you. This proves that the particles are water. Water is made up of particles. They have some space in between them. When you add salt to this beaker, the particles of salt dissolve in water. They basically go and occupy the spaces between the water, and hence the level after adding salt does not rise, because salt just fills the spaces that are existing between water particles. This activity proves that matter is made up of particles, small and tiny particles, and it differs. In solids, those particles are heavily attracted to each other and they are very close by, but in liquids they have some spaces. In air it has bigger space than liquids, and these particles are constantly moving. So if we were to discuss some characteristics of particles of matter that we should remember during the whole chapter or during all the sessions that we would be discussing, is that matter is made up of particles. Matter is made up of tiny particles. These particles of matter are continuously moving around, or they are vibrating, though we don't notice the movement, but they are continuously vibrating or continuously moving. Particles of matter have space between them. As we saw through the activity, when we mix the salt with water, the level of that beaker did not rise. The level of water in that beaker did not rise after adding salt. It was because salt went and occupied the spaces that were between the particles of water. Hence, particles of matter have space between them, and particles of matter attract each other. These are 4 characteristics of particles of matter that we must always remember. Now, we know that particles attract each other. We know that they have spaces between them. We know every matter that we see. Almost everything in this entire universe is made up of matter. So, now we know that water is also matter and water is liquid. But we know that it can exist as ice, it can exist as liquid water, and water after heating up to 100 degrees Celsius turns into steam. So one matter that is named as water in one state can exist as ice, as a solid, it can exist as a liquid, and it can exist as a gas. In other words, water is found in all 3 states. These states that I just described, solid, liquids, and gases, are 3 different states. There are different forms in which a certain matter can exist. In physics, we say that a state of matter is one of the distinct forms in which matter can exist. 4 different states of observable states of matter are solid, liquid, gases, and plasma. Plasma is a highly different form of state of matter where matter exists as charged ions. You don't have to go deeply into understanding plasma because our study will be focused on the 3 states of matter we generally see around us, that is solids, liquids, and gases. We know water exists in all 3 different states. The form in which matter will exist is called a distinct state. Each state has different properties that we would be discussing later. We know that matter around us is usually classified into 3 general states as we just discussed. One of them is solids, the other is liquids, and the third is gases. We say wood is a solid, we say oil is a liquid, we say oxygen is gas, we say a glass is a solid, we say the pen that you're holding is a solid. But then how are you able to classify this particular pen as a solid, or water that you drink as liquid, or oxygen, air that you breathe in as a gas? So there are properties and characteristics, or there are rules that help you classify or help you recognize this particular matter that we see is either a solid, the other that we see is a liquid, and the other that we see is a gas. Let us discuss this further. Shape and volume are 2 different properties of matter, and we are going to discuss the shape and the volume of solids and liquids. If you take a container and if you put a pen inside this container, you will see that the shape of the pen does not change, or even the boundaries of the pen does not change. Nothing changes. This is a different solid and the pen is a different solid, and it remains as it is. But if you pour water in the same container from another container, you will notice that water first took the shape of the container it was earlier in, and then water takes the shape of the container that you put it in. This basically will help you recognize that the shape of the liquid will depend on the shape of the container it is put in. Though liquid takes different shapes, it depends on the shape of the container, but the volume remains the same. If you pour 5 ml of liquid from a glass bottle into a glass beaker, the volume will still remain 5 ml. It will not change. The shape will definitely change, but the volume will remain constant. It will remain 5 ml. These liquids, since they flow easily, they are called fluids. Everything that we just discussed helps us conclude that solids have a definite shape and have a definite size and have a definite volume that does not change whether you change if you put them inside a container or if you do other things to them. But if you do the same with liquids, for example, try and putting them in other containers or try and applying force on them, they will not have a definite shape, or the shape that they are used to will not remain constant, but the volume that they are using will remain constant. So this is a property that helps us classify matter as solid or as a liquid. Solids, if they have a definite shape, if they have distinct boundaries, if they have a definite volume that does not change at all, then the matter that you see around you, that will be a solid. If the matter that you see around you does not have a definite shape, the shape depends on the size and the shape of the container that it is in, it can flow easily, and it has a definite volume, then the matter would be classified as a liquid. Why do liquids flow easily is also depends on the fact that the molecules of any liquid is made up of, the particles of that liquid, they are not tightly bound to each other as in solid. If you see in the diagram that has been presented to you on the right hand side, you see solids, they are vibrating and they are closely attracted to each other. But on the top, you see that the molecules of liquid or any matter that is liquid, they have some space in between them that helps them slide over each other or helps them move. This is why they can change their shape that easily and take the shape of the container or any beaker that they are in. But solids cannot do so. They cannot slide over each other. They are closely packed. The molecules that make up a solid, they are closely packed. Let us now discuss the shape and volume of gases. As you see the air around you, it's there and you can move your hand over it and you can cut through it and you wouldn't feel anything. It is because gases, neither do they have a fixed shape, neither do they have any fixed volume. If you see those blue dots that are moving around each other on the top right hand corner, those are molecules of a gas. Gases have a lot of space in between them, and that is why neither do they have any fixed shape, neither do they have any fixed volume. They can keep rotating, they can keep moving and have tons of different properties that will help them be either compressible or either be flexible, and since they can easily flow, they are also fluids. Gases are highly compressible due to this one property that gases have a lot of space in between them. Gases are highly compressible. LPG gas that we get in our home for cooking, or that oxygen that is supplied to hospitals, that gas cylinders has compressed gas inside it. Or even CNG, compressed natural gas, is used as a fuel in vehicles. It is due to the high compressibility that large volumes of gas can be compressed into a small cylinder and it can be transported very easily. In conclusion, to determine the basic properties of shape and volume for solids, liquids and gas, we say solids are rigid, they have a fixed shape, they have a fixed volume. Liquids, they are not rigid, they have no fixed shape, but liquids have a fixed volume. Gases are neither rigid, neither do they have a fixed shape, neither do they have a fixed volume. If you see in the diagram that has been presented to you on the left hand side, you see a solid plate and then you see a magnified view of it. The magnified view shows you how small particles that are making up that particular solid plates are attached to each other. They hardly have any space around them. Liquid, when magnified, you see that they have some space around them that helps them slide over each other or move around each other. On the other hand, the magnified view of a gas shows you that they have a lot of space between particles that make up a gas, and hence they can move around very easily, and very less particles are obstructing another particle's path. Let us talk about compressibility. Compressibility means how much you can basically change volume of a matter. Compressibility is the measure of how much of a given volume of a matter decreases when pressure is applied to it. So, if you take a piston and if you were to push a cork through it, if you add a chalk powder between the particles and then if you try and push the piston, and if you try the same activity with water and then with air, you will see that you will be able to push the handle of the piston easily when there is air between them, a little fairly easily when there is water, and it will require a lot of force when you have to pour through the chalk powder to get through the cork. If you look at the diagram that has been presented to you on the left hand side, this is what the activity represents. If you put pressure on a solid or a liquid, there is essentially no change in volume. The atoms or the ions or any molecules that make up a solid or a liquid, they are attached closely together. But this is not the case of air. In air, the molecules are not closely packed together. They fly away, they have a lot of space, they can move around easily. That is why you can compress them or bring them closer and decrease the volume of a particular gas very easily. Let us now talk about diffusion. Diffusion is